Up on the board over here on the left-hand side, I wrote down identities that we already know, definitions that we already know. I know that x squared plus y squared is equal to r squared. That's our Pythagorean theorem. I know that sine is equal to 1 over cosecant. Cosecant is equal to 1 over sine. They're reciprocal functions of one another. Same with cosine and secant. They're reciprocal functions. Tangent is 1 over cotangent. Tangent also equals sine over cosine. So therefore it makes sense that cotangent would equal cosine over sine. All right? Now we have another one that I wrote up there, and that's called the Pythagorean identity. Pythagorean identity. Sine squared plus cosine squared equals 1. Okay? Now, I'm going to show you why that's true. And I'm going to use definitions to show that this is true. All right? Well, first of all, by the way, cosine squared plus sine squared is the same as sine squared plus cosine squared. Okay? So that's no big deal. All right. What is cosine squared now in terms of definition, in terms of x's, y's, and r's? What is cosine? X over r, right? Cosine is x over r. Cosine squared is x over r squared. Sine is equal to y over r. And sine squared would be y over r squared. Okay? I want to show that that's equal to 1. Unlike geometry, where you have to give reasons, in trig you just have to do the work. So it's going to rely a lot on your arithmetic skills and your algebra skills. Mostly arithmetic. Dividing fractions, multiplying fractions together. Right? Okay, so we're going to show that that's equal to 1. Well, I've got x squared over r squared, that's your algebra skills, plus y squared over r squared. Okay? And now I have two fractions with a common denominator already. X squared plus y squared over r squared. Show that that's equal to 1. Well, what is x squared plus y squared? R squared. We've already learned that. We've already learned that x squared plus y squared is r squared. So now I have r squared over r squared, and that's 1. That's using definitions to show. Okay, your definitions are your x's, y's, and r's. Definitions. On your homework tonight, you have two problems where you have to use definitions to show that one side equals the other. Problem number 9, problem number 11. That's where you use your x's and r's. All right? Okay, well, let's do some other algebra skills. Now that I've shown that sine squared plus cosine squared equals 1, now I can use that. I can also use some algebra skills. If I subtract sine squared from each side of this Pythagorean identity, just subtract sine squared, I will get cosine squared theta is equal to 1 minus sine squared theta. It's just another form of that Pythagorean identity. And similarly, if I subtract cosine squared from each side, I would get that sine squared theta is equal to 1 minus cosine squared. And these are identities that we can use. There are 3 Pythagorean identities. Here's one. You've got the one plus two other derivations of that. The other one, tangent squared theta plus 1 is equal to secant squared theta. That's another one. Let's use definitions to show that that's true. I know tangent is y over x, correct? Yeah? Okay. So y over x squared plus 1. Show that that's equal to secant squared. Use definitions. Y squared over x squared plus, well, instead of 1, I'm going to write x squared over x squared. Because that's 1, anything over itself, right? So, because I have a common denominator, I can add the numerators together. What is y squared plus x squared? R squared, right? Our Pythagorean identity. So I have r squared over x squared. And by definition, that is secant squared. Okay? So that's how you do a trig proof. It's just using your algebra skills. All right. Now the third one. And you could play around with this too. Tangent squared theta minus secant squared theta equals -1. Secant squared minus tangent squared equals 1. So you can sort of play around with that too. So there's 3 forms of that. Then you have cotangent squared theta plus 1 is equal to cosecant squared. And that's another one. Now, if you look on page 903 in your book, turn to page 903 in your book. Turn to page 903 in your book, for those of you who have your book. And you're going to see a blue highlighted box right in the middle of the page. And it has those identities in it. So what you'll probably go back and forth as you're doing your homework. Okay? So let me show you how we're going to use these. This is an example, this first problem here, cosine squared theta over 1 minus sine theta. Your next set of directions, and this is on page 906, your first set of directions say, or second set, write each expression in terms of a single trig function. Here's what you have to do in this area. As a single trig function. Right now, I have cosine squared over 1 minus sine, so it's in cosine and sine. I want to write it in terms of one trig function. All right. Well, by what I've just learned, cosine squared is 1 minus sine squared. Cosine squared is 1 minus sine squared over 1 minus sine. We're almost done. Can I reduce that? The answer is yes, you can. This can be reduced. How do you reduce it? That's the question. You can't start crossing off things. Don't tell me that. You can't cross off the sine on the bottom with the sine squared on top. That's not going to work. Anybody see anything? Yeah, it's kind of.
Just totally take out the 1 minus sine since it's like connected.
No, you cannot. You can't do that. How do you reduce fractions? We've had this before. Think about, oh, they've got it. Yeah, not the conjugate. Jack wants to multiply top and bottom by the conjugate. You know, you may be able to get there, but it's a long way around. There's a simpler way. Anybody see it? Really? Nobody sees that?
We just square the bottom.
You can't just square the bottom. Yes. Yes, Andrew. And how do you factor it?
1 plus sign, 1 minus sign.
Perfect. If you look at the numerator, it's a difference of 2 squares. And it would factor into 1 minus sign, 1 plus sign. Over the bottom one, which is 1 minus sign. You got to be careful because the only time you can factor, the only time you can reduce is if you factor first. And the top is a difference of 2 squares. Now I can cross off 1 minus sign, 1 minus sign. They're the same. 1 plus sine of theta. Now I've written my example in terms of one trig function. Okay? Let's look real quick here. All right. Second example. Your directions will say, write in terms of cosine. Remember what I said. Everything can be turned into sines and cosines. And I'm going to write that one in terms of cosine. Right now it's in terms of secant, tangent, sine. Go back to your notes. Go back to this first column over here. First column and second column. Page 903, it's all there. And use your identities. Secant is 1 over cosine. Minus. Remember, I want to turn everything into cosines. Tangent is sine theta over cosine theta, right? Times sine theta. Order of operations, say you do your multiplying first. I have sine theta times sine theta, which is sine squared theta. 1 over cosine theta minus sine squared over cosine theta times 1. Bless you. I have 2 fractions here, and they do have the same common denominator. So I can write that as 1 minus sine squared theta over cosine theta. And what is 1 minus sine squared theta? Cosine squared theta by our Pythagorean identity right here. So I have cosine squared theta over cosine theta. That can be reduced. Okay? That's how you would do problems in your homework from the next set where it says write each expression in terms of cosine. The next block of problems say write each expression in terms of sine. Then the last one says, these can be tricky. I don't think these are particularly in your homework, but use identities to verify that each statement is true. Now, in geometry, when you did proofs, I'm not sure, but I think you were only allowed to work one side of the equal sign, not both. Well, that's what we're going to do with trig. Only work one side of the equal sign. So here's your question. Do you want to work the left the left side? Do you want to show that tangent squared is equal to secant times sine?
Which one would be easier to work with?
Well, that's what you're going to decide. I think the right side would be easier to work with. Well, where would you go with tangent squared? It'd be sine squared over cosine squared. Then where do you go? All right. So if you look at that right-hand side, remember what I said. Turn everything into sines and cosines. So I know that secant squared is 1 over cosine squared times sine squared. And we'll put sine squared theta over 1. And this is a little bit easier than a geometric proof. 1 times sine squared is sine squared. Cosine squared theta times 1 is cosine squared. And by definition, sine squared over cosine squared is tangent squared theta. Okay. Somebody earlier in the day said, well, when you're doing these, you have to show your work. Well, yes. I got to figure out how you got there, right? You can't just say tangent squared equals tangent squared. Okay?
But yeah, you can just do that.
Yeah. Because I'm telling you it's true, you got to show me it's true. All right. So, for your homework tonight, make sure you guys have this done. Oh, by the way, our quiz is on Wednesday, and we've covered everything that's going to be on your quiz. All right, for chapter 14. So for your homework, you can do page 906 and 907. I gave you the odd problems, and then 59 through 62 all. And for 59 through 62, in the book, you're going to have to read example 5. It's easy enough. It's a formula. Put those numbers in a formula. And this symbol that you will see in that formula, that is a Greek symbol. It is mu, M-I-E-U, I believe. It is called mu. Okay?